Have you ever stepped on something small and been surprised about how much it hurt? It's tiny, it's light, but somehow it causes a lot of pain. Today, you're going to see why that happens. By the end of this demo, you'll be able to say, I can explain how pressure depends on force and area, and I can describe how spreading weight out reduces pressure. This cup is going to help us explore a big science idea, pressure. Pressure is defined as force divided by area. The force in this demonstration is my body weight, caused by gravity pulling me down towards Earth. The area is how much space that force is spread across. When the area is small, the pressure is high. When the area is large, the pressure is low. So for my first cup, I'm just going to stand on it. I'm going to crack. So my weight didn't change, but the cup collapsed instantly. Why? Because all of my force was concentrated onto a very tiny area, the top rim of this cup. That created a lot of pressure in one small spot. The material of the cup simply couldn't withstand that much pressure, so it failed. This is an important idea in physics and engineering. Materials don't just respond to how heavy something is, they respond to how that weight is distributed. Okay, what if I use 2 cups, one for each foot? That should help, right? I've doubled the area. Still crushed. Even though the area increased a little, the pressure is still too high for the cups to handle. My weight is still concentrated into small points. Now let's try something different. I'm going to use 13 cups and add a large, thick piece of cardboard across the top. Notice what I'm changing here. I'm not changing my weight. I'm only changing the surface area over which the weight is spread. The cardboard acts like a platform, helping distribute the force across all 8 cups instead of just 1 or 2. And now I can stand here without crushing the cups. Same force, completely different results. Because the area increased, the pressure decreased. This is called weight distribution, and it's a principle used constantly in engineering design. When engineers design structures, they don't just think about how heavy something is, they think about how to spread that weight safely. Think about what would happen if a building's weight were supported by a few narrow points instead of a wide foundation. The ground underneath would crack or sink. That's why buildings have large foundations that spread their weight across a big area of soil. The same idea applies to bridges, roads, tires, and even furniture. Wide supports lower pressure. Narrow supports increase pressure. This is also why wearing snowshoes lets a person walk across deep snow without sinking. The snowshoes spread your weight across a large area, lowering your pressure on the snow. Animals use this too. The snowshoe hare has large, furry feet that act like natural snowshoes so it can run across snow without sinking. Similarly, in the desert, the camel has wide, padded feet that keep it from sinking into sand. Same physics, different environments. This explains why stepping on something very small can feel so painful. Your entire body weight is focused onto a tiny point on your foot. High pressure over a small area triggers pain receptors immediately. Engineers design building foundations, bridges, tires, and even high heels with this idea in mind. If weight isn't spread out properly, structures crack, sink, tip, or collapse. This also shows why heavy trucks have multiple wheels. More wheels mean more area touching the road, which reduces pressure on pavement and prevents damage. This concept also shows up in nature and earth systems. Snow, sand, soil, mud, and even ice sheets respond differently depending on how force is distributed across them. Hikers sink into mud more when they wear narrow shoes than when they use wide boots. Vehicles get stuck in sand when their tires are too thin or underinflated in the wrong way. So remember these key terms. First, pressure equals force divided by area. Force is the weight from gravity, area is the surface the force is spread across, and weight distribution changes everything. Nothing about my weight changed during this demo, only the area changed, and that made all the difference. So now you should be able to say, I can explain how pressure depends on force and area, and I can describe how spreading weight out reduces pressure. And the next time you step on something small and it hurts, you'll know exactly why.